In mathematics, an integrating factor is a function that is chosen to facilitate the solving of a given equation involving differentials. It is commonly used to solve ordinary differential equations, but is also used within multivariable calculus when multiplying through by an integrating factor allows an inexact differential to be made into an exact differential. This is especially useful in thermodynamics, where temperature becomes the integrating factor that makes entropy an exact differential. Use in solving first-order linear ordinary differential equations. Integrating factors are useful for solving ordinary differential equations that can be expressed in the form. The basic idea is to find some function, called the integrating factor, which we can multiply through order in order to bring the left-hand side under a common derivative. For the canonical first-order linear differential equation shown above, our integrating factor is chosen to be in order to derive this. Let be the integrating factor of a first-order linear differential equation such that multiplication by transforms a partial derivative into a total derivative. Then, going from step 2 to step 3 requires that, which is a separable differential equation, whose solution yields in terms of. To verify, see that multiplying through by gives by applying the product rule in reverse. We see that the left-hand side can be expressed as a single derivative, and we use this fact to simplify our expression to we then integrate both sides with respect to. Firstly, by renaming to, obtaining finally, we can move the exponential to the right-hand side to find a general solution to our ODE. In the case of a homogeneous differential equation, in which we find that where is a constant. Example: solve the differential equation. We can see that in this case multiplying both sides by we obtain reversing the quotient rule gives, or which gives general use. An integrating factor is any expression that a differential equation is multiplied by to facilitate integration and is not restricted to first-order linear equations. For example, the nonlinear second-order equation admits as an integrating factor. To integrate, note that both sides of the equation may be expressed as derivatives by going backwards with the chain rule. Therefore, this form may be more useful, depending on application. Performing a separation of variables will give this as an implicit solution which involves a non-elementary integral. This same method is used to solve the period of a simple pendulum.